In this example, we're going to solve the equation log x plus log x minus 21 equals 2. So we know when we solve an equation, we want to isolate the variable, get the variable by itself to find values of that variable that will make the equation true. We can see the variable here appears twice. It appears as the argument of the first log and as the argument of the second log. So if we want to be able to solve for x, we need to combine those together. And we can actually combine the sum of two logs that have the same base. We can combine them using the product of those arguments. So we have that rule. If we have the sum of two logs, we can rewrite. So we can rewrite as log of x times x minus 21. So I've multiplied the two arguments and combined them into one logarithm. Now this is useful because the variable now only appears in the argument of this one logarithm, and we know we can rewrite logarithmic equations without logarithms by writing the equivalent exponential equation. So we know that if the base is not written in, we assume it's a 10, so this is a base 10. So then this can be rewritten as 10 squared equals x times x minus 21. Well, now we know 10 squared is 100, and we can actually distribute on the right side x squared minus 21x. So we see we now have a quadratic equation, and we know how to solve quadratic equations here. So we can subtract the 100 over to get the 0 on one side. And now we can try to factor, usually a very convenient way if it does factor. So we set the 0 here. We'll do our trial and error. First two terms would have to be x to multiply to give x squared. The last two we need factors of 100, so we could try 25 and 4. And it's a negative 100, so we need a negative and a positive. And if we check our outer and our inner products, x times 4 is 4x, negative 25 times x is negative 25x, 4x and negative 25x will give us negative 21x, so we know that works. So now if we have our two factors that multiply to equal 0, we know that either x minus 25 is 0 or x plus 4 is 0. So obviously here we get x is 25, and here we get x is negative 4. So with our logarithmic equations, remember we must check for extraneous solutions. We have to make sure when we substitute the values of x back into the original equation that we don't end up taking the log of a negative. So I'll substitute my 25 back in here. So if I put 25 in for this argument, I'm good. It would be log of 25. And here if I put the 25 in, 25 minus 21 is 4, so log of 4, that's okay. So we can definitely circle our answer of 25. But the negative 4, if we substitute that back in here, we'd end up taking log of a negative. Same thing here. If we put the negative 4 in here, it would be negative 4 minus 21, negative 25 for our argument. So we exclude that. Again, that's because the argument would be negative.